Hello everyone, my name is Rizwan and welcome to the Nowhere. So today we will be solving a very interesting problem from the lead code problem sheet, which is valid Sudoku. What we had to find if a Sudoku, if a given board is valid or not. So how are we going to find that? We basically have three conditions. If those three conditions check out for each and every element of the matrix or every element of the board, then we can say it is a valid Sudoku, right? So what I mean by that is, for example, if we take element 5, which is at index 0, comma 0, so we'll first check all the rows, all right, all the columns, sorry. If the element is present in the respective column, if it repeats itself in the respective columns, then it is not a valid Sudoku. Also, if it another condition is that if it is present, if it repeats itself in the respective rows, then also it is not a valid Sudoku. And the third condition is that if it okay, if it repeats itself in this square, which is also a matrix or a subset. This is the matrix. If it repeats itself in this matrix or any other matrix, okay, these are the matrices, then it is also not a valid Sudoku. So what I mean by that is, if 5, first of all, it has if it is present in the respective columns, then it is not a valid Sudoku. Also, it is if it is present in the respective rows, then it's not a valid Sudoku. Also, if it is present in the given, uh, if it repeats itself in the given matrix or subset, then also it is not it's a valid Sudoku. For example, 5, if 5 is present here, see after if it is if 5 is present here also in this cell, then also it repeats itself in the same subset or same matrix, then it's not a valid Sudoku. But as you can see, 5 is present here, but it will be considered valid because the matrix is not same. This is another subset, all right? This block is different from this block, right? So let's move on to uh, write a proper code for this. So first of all, what we'll do is we'll create a dictionary for columns, rows, and squares. Okay, so this is columns, rows, and squares. So first of all, what we'll do is we'll create indexes. These are going to be J for columns, and this is I for rows. All right. But also we can create index for the squares also. All right. So this is 0, this is 1, this is 2. All right. Similarly, this is 0 for this square, this is 1, and this is 2. This can be considered for index of the matrices, yeah, of the sub matrices. So first of all, how we are going to approach this problem? First of all, for we are going to iterate from range, which is the length of the board. The length of the board is 9, right? And also another we are going to iterate first of all we are going to iterate from rows. The length of the board will give us the number of rows present in the matrix, and and we are going to for j in range board of 0. So it will give us number of columns. Okay, for example, if I is 0, then first of all we will iterate from here. It will iterate in the columns section. Oh, okay, another uh, line here, it is a value. It represents each and every value that we are going to iterate. Right? So board ing, value of board ing. So value will be each and every value that that we are going to iterate. Okay, now comes the conditions. For example, if board ing is equal to dot, then what we are going to do, we are going to do nothing. All right, we are just going to simply continue. So because it doesn't matter. Okay, this is the input that we are going to get. If it is dot, then it doesn't matter. We'll simply continue our operation. So if value in rows, if value is present in the rows, all right, then what does it mean? If we are iterating on 5 and it is already present in a row, so what does it mean? It goes against the first condition, that is no call, or I think it is second condition, that okay, would okay, yes, if value is present in the rows, then it goes against the second condition. It means that it should not be, it is present in the rows section. So value is already present in the row section, which should not be the case, because it goes against the first condition. It violates the first condition. So obviously, if that happens, then we have to stop our operation, and it will return false. If that is not the case, then what we are going to do, we are going to simply add it into the row dictionary, right? Another simple same similarly, what we are going to do is we are going to add, if we are going to check if the value, that is, if for example, if 5, we take 5 here, it has an index of 0 comma 0. If it is present in j, all right, so we know that nothing else gets appended before, so 5 is gonna get appended in each and every case, and then the comparison will start. So if value in columns j, uh, if value is in columns, so 5 or 3, if we take, if it is in columns, it is going to check back. It's not going to check for forward values. It is going to check for the values that it has already iterated over. All right. So for example, if 3 is there, right, it means 5 has been iterated already. If the current iteration, if the current pointer is at 3, that then it means that the 5 has been already iterated, and it has been saved in the previous columns and rows, and also in the squares. So if 3 is already present in the previously iterated values, then it will return false, because it violates the condition. If not, then it is going to get appended. Uh, Similarly, what we are going to do is we are going to append. We are going to uh, we are going to you know break the whole matrix in 3 cross 3 matrices. It is which will be total number of 9 boxes. So this matrix, what is the index going to be, as I explained earlier? So it has an index of 0 comma 0. All right, so all the values present in this will have an index of 0 comma 0. So for example, if we take 5, if we take I is equal to if we take 5, for I for 5 is 0, and j for 5 is also 0. So 0 divided by 3, 0 divided by 3, it be equal to 0, and it is going to check if it is in squares. If it is in squares, then it will return false, and if it is not in the squares, then it is going to append it. All right. It is not necessary that we should append, for this case to work, we should append it inside the squares, because After we have checked the element for columns and rows, we are now going to check it for the squares. So if the value is in squares, first of all, what we'll do is we'll create the indexes for the respective squares. All right. For how we are going to do this, we are going to obviously part the total board in nine squares total. All right. So this is one. This first square have will have an index of zero, second one, and third two. All right. Similarly, zero, one, two. So every element present in this zero comma zero. All right. Zero comma zero element will, after dividing it by three and j divided by 3, so it will become as 0 comma 0. So that's how we are going to divide it and put the index of the respective matrix. And after dividing it, it is going to look like somehow look like this. So for so for matrix sorry so for square 0 comma 0, which is this. Okay, 0 comma 0 will act as this matrix 5 3 and empty. Okay, the elements that will be appended inside it are 5 3 6 9 and 8. So 5 3 3 6 9 and 8. So 0 comma 0, that's how we're going to append it, right? uh, we can take another example. So this one is a tricky point here. We can take another example. For example, if we take 6, all right. So 6 has an index of 0 and no, it has an index of 1 and 0. All right. So I will is equal to 1. I divided by 3. It will give 0. J double 0 divided by 3 will also give as 0. Our board value will be equal to 0 comma 0. So if the values are in this will act as our key value. All right. So and then we are going to append it. If value is in 0 comma, board value for 6 will be 0 comma 0. All right. So if the value is in 0 comma 0, then it will return as false. Otherwise it is simply going to append it. All right. So this is how our matrix or our squares are going to look like. So these are examples of the first 1 2 3 4 5 6 matrix, six parts of the matrix and the elements in it. All right, this is how it is going to look like. Okay. These are the parts. That's how it's going to look like. I hope you are able to understand this. Let's move forward to our next point. Okay, if all the conditions check, if the all the conditions get satisfied, then we will return true, and this will solve our problem. I hope I was able to make you understand this. If you like this session, please do like, share, and subscribe. If you're watching it on Facebook, do follow the page. Thank you.